Similar figures have a different size but same shape. For example, we have two triangles. One is smaller than the other, but they are the exact same shape. And we're going to talk about proportions relating to this because each triangle is proportional to the other. Notice, I've color-coded sides that correspond. So we have the shortest side corresponding with the shortest side of the larger triangle, and then the medium side, right, and the longest. I'm going to call the smaller triangle the original figure and the larger one the new figure. Notice a pattern. I have gone from 3 to 6, 4 to 8, and 5 to 10. What I've done each time is multiplied by 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. To get from our original to new, we've multiplied each of these side lengths by 2, and the term for that is scale factor. We have enlarged or made larger this triangle by a scale factor of 2. Here is how similarity relates to proportions. I can use proportions to find missing side lengths of similar figures. So if I know that I have these corresponding sides that are color-coded, right? 4 corresponding to x and 3 corresponding to 6, I can set up proportions to solve for x. Here I've compared 4 and 3, right? The medium side to the shorter side. The same comparison can be made for the other figure, the medium side to the shorter side. So 4 over 3 is equivalent to x over 6, which is what I have here. Now I use what I know about proportions to solve for x. Well, 3 times what number is 6? We know that that is 2. So if we multiplied this denominator times 2 to get to the new denominator, we need to do the exact same for the numerator. So 4 times 2 gives us x, while 4 times 2 is 8, so that means that x equals 8, and therefore this side length up here is 8. Now there are many different ways that you can set up proportions for the same problem. Previously we did 4 over 3 equals x over 6. The reason this works is we are comparing corresponding sides. So I have the medium side compared to the small side of my smaller triangle, right? Now over here, right, that was medium over small. Over here I have the medium side compared to the small side of my larger triangle. So my medium side over my small side. I could have also written 3 over 4 equals 6 over x. It's the inverse of the first thing I wrote. So instead of doing medium over small, I did small over medium. Small over medium. So I'm still comparing corresponding sides, right? If I'm going to go 3 over 4, small over medium, then that has to equal 6 over x, small over medium. You could also say 4 over x equals 3 over 6. So we're still matching up corresponding sides, but now we're comparing across these triangles. So 4 over x, right, the medium side over the medium side of each triangle, equals 3 over 6. I'm comparing smaller to smaller. The last way you can do it here is x over 4 equals 6 over 3. Now we're starting with this triangle and going backwards, but we're still matching up corresponding sides. So the medium side over the medium side, the small side over the small side, right? X over 4, 6 over 3. So the whole point of all of this is just to understand that you have corresponding sides, right? Basically what would be the same side of each of these triangles, except one obviously is larger or smaller than the other, and you are matching them up. That's all that this is, and if it helps you to color code when you're doing these types of problems, that would be very, very useful.